with that, thank you so much for being here. Let's see a little of what we will do here. We will talk about what is AI because before we can talk about generative AI, we need to talk about AI more broadly. It's one of those nebulous terms that I was thinking about it. And I want that you leave this workshop understanding what exactly is AI and what exactly is not AI. And spoiler alert, it's not magic. So we will see how is the progress of all these definitions. Um, then we will see exactly what is stable diffusion, which is the model that we use to use generative AI. And I will explain why this model in specific as part of my presentation. And then I will explain you how to train a stable diffusion. It's very easy. If you have a little knowledge of Python, it's not that much. Python does almost everything for you, I promise. And then how to use it in a project, meaning how to convert that to an API that you can connect at any moment in any project. I hope that you find this whole workshop useful. A little of learning objectives. I will show you how to train a model of generative AI and how to use it in a project. But for me, that's not the biggest learning that you will get at the end of this workshop. For me, I'm specifically a particular interest that you understand the difference between artificial intelligence and machine learning. And because I see a lot of people using these terms interchangeable and they are not. And I would like, as an educator, to tell people, please stop doing that because it's only confusing the field. Understanding where generative AI came as a subset of deep learning and understanding the difference between deep learning, machine learning, and generative AI. Understanding the idea of a foundation model. Stable diffusion is the foundation model for a stable diffusion. And I want that at the end of this workshop, you understand the idea of a foundation model and why are you using a foundation model. And that you can use that because it's a foundation model, it's expected that you fine tune that model and use that model with your own image and your own ideas for your projects. And most of the tools that I will present to you are free or very cheap because they're the available tools on internet for doing all of that. So first, let's start with what is AI. AI is a discipline that deals with creating systems. We call that intelligent agents that can act automatically. One way of thinking about it is that AI is a field like physics or math. It's the whole idea. So machine learning is a subfield of artificial intelligence. And understanding that when we are talking about AI, we, as a field, we can understand the machine learning is a subfield and has several techniques, many of them that you can use for something that is called deep learning, which is the next concept. Well, the next concept is, no, sorry. The next concept is machine learning because machine learning is the field of students programs or systems designed to train models for making predictions based on input data. Machine learning gives the computer the ability to learn without explicit programming. Is the thing that is the field that study the process for training the software to make useful predictions or generate data or generate content through a thing that is called a model. And there are two types of models, the supervising models and the unsupervised models. In the supervised models, understanding this one is super important for understand generative AI. So in the supervised models that you are seeing here, you have the input data and the model is just a collection of algorithms, and you train that model with some data, and the model will try to run the data to predict the output. And if the output and the train data you need to compare those two. And if they are very different, that is called an error. And if you have an error, you have to update the model. Because the idea is that the predict output will be very similar to the expect output on the train model. I don't know if you are understanding this idea of training something to do something. It's the whole concept that you have, like you bring to the computer a bunch of photos of cats, and then you train the model to understanding what is a cat only with the photo, and then you pass the model a photo of a dog, and if compared with the training model of being a cat, and it says with the photo of the dog, no, this is a cat, then you have an error. Then you have to update the model until the model compare a cat with a cat, and then you have a foundational model. This is the basic of generative AI also. In the unsupervised model, you just put the input and the model generate an example. These are the kind of models that we use, for example, with sentimental analysis. You put a lot of, I don't know, tweets to programming, and the programming will tell you if it sounds joyful or if it sounds sad, with some sadness, or if will recognize some kind of conflict. But here you don't have a training model. In the supervising models, you have a training. And this is important because it brings us to the next level of machine learning, which is deep learning. Deep learning is a subset of machine learning, which is basically a collection of methods to training the computer with something that is called neural networks. And it's very important because no, sorry, neural networks they bring the idea of training a computer like you train the brain, the human brain. It means that you have a bunch of neural connections with not only the model, also with the output. And each one of the connections will make the model learn. And when I say learn, I'm using the term in a huge level. It means recognize if the data is similar to the data on the training model or not. It's not learning, real learning, like human learning. But this process of using neural networks and the invented of them is where gave us the possibility of getting to the generative AI field. And that allowed me to show you generative AI is a process inside deep learning. And it's a process that they train labeled data on labeled data and all kind of data. It means that it gives unsupervised. It means that you can bring to generally supervised models, unsupervised models, and semi-supervised models. And that's the cool thing about generative AI, that allows us to work with all kind of models to bring the idea of creating something that didn't exist before. So now the model, the computer, is not only comparing or classifying information, is creating new information for us. So I show you at the high level this idea of unsupervised, the supervised learning process that it was creating um, with input data and expected data and model depending of the thing that you need the computer to do. So classify or organize for clusters or something. Um, the process in generative AI is more robust because you just bring unstructured content. It means that it could be any kind of data as the input for the model, and the model, you can add as many machine learning models as you needed to create a foundational model. For as example, the perfect example for that is stable diffusion, and the output of that will be new content, which is something that doesn't happen before. And this new content could be text, code, image, audio, video. We are seeing that now there are companies doing generative AI and pretty much everything. Um, so the foundations models that we use in generative AI are machine learning models. So it means that are the basic models that we used to use for doing just one downstream task, for sentimental analysis, for image caption, for object recognition, for text recognition. But now in generative AI, we are using all of them. For example, stable diffusion use three different machine learning models. And the magic of that is that because it's using neural networks, it allows that. So when you are seeing something like this in a computer, it's just a connection of it's just a matrix with vectors, which is just numbers. It's a matrix of numbers. So now we can see on general AI that these stable diffusions are huge matrix with vectors that could be run in a GPU. And that is the magic of this thing. But it's not that the computer is doing magic, it's that we are working on the shoulder of giants. Everything that was built for machine learning, we are using now in generative AI in a conjunction. But it's just that the computer science field has been learning how to do these computations faster and in less individual weights. So now we can conjunct um, networks and stable diffusion in models. And I'm giving you all this background because I don't want that you think that generative AI is magic. It came from a long list, a long history of new challenges and new discoveries. Um, Wikipedia, you can search on Wikipedia the timeline for machine learning, and you can see every single advantage that allows to the machine learning process to move to the next level, starting with the idea of probabilistic interference, which is something that people in statistics will see. I find funny that we have something called AI winter on the 70s because people stopped believing in AI in the 70s. Um, and in the opposite field, only until 2010, deep learning become feasible because we developed this GPU that could trade huge matrix of vectors in just one space. And I will show you this one a little more deep in a minute. But again, all of this is to please note that it's not magic, it's just an evolutive field of developments that has allowed the computers to take decisions. simulate the human brain, but it's just a simulation. So this now let's start working up talking about how does stable diffusion work. So again, stable diffusion is the foundational model that is used on generative AI to work to create new image. It works very well in image, and is very powerful because it has worked very well in with low computation machines that are actually not that low, but low in comparison with other models. So the idea here is that given a large enough data sets, this model can learn complex operations. So you can see here, everything is actually explained here in this diagram. And let me see if I can annotate. So here are the three machine learning models that diffusion works, the stable diffusion works. Let me see if I can show you. So here, this X will be your image. And the idea with your image is that you want to train the model to recognize this image. What is in this image? Let's skip this E for the moment. So what are you doing is the diffusion process that I will explain in a minute, but this is a machine learning process. So you put the X through the diffusion process, and then you get to this thing that is your image after the diffusion process. Bear with me a minute. I will explain this in a minute, but a high level. And then you do the opposite here. Now that you have this CT, you do something that is denoising, which is another machine learning process. So this is the second one. And then you get to this X. And in theory, this should be equal. And if they are not equal, you need to redo the process. Now, because we are working with image, usually images are super huge, are 512 by 512 pixels, or we can even have more bigger image. So computers could not do this whole process with so many pixels, right? Imagine that you are converting every single pixel to a 0, 1, 1. It will be a huge amount of data. But then they realized that they could do this process, which is also a machine learning process, which is called encode, and basically is reduce the image to a minimal matrix. And now you have your image, but you pass first the image for your encode, and then you have a minimal matrix, which is still valid. And then you submit this little matrix to the diffusion process, and you have this CT thing, and then you do the other. But now when you are here, you decompress the image. And with decompress the image, you can see after decompress this little matrix, you will see the image that is the result of the process, and hopefully it's equal to the one that you give to the training process. Now, why I'm talking about image when with creating something, you just give text. Well, that's the third one machine learning process, and is that stable diffusion also convert the text to a matrix, which allows to bring each one of the words to the idea, to the representation of the idea that you want to see. So the process starts here, with the text that generate this image, which is the image that you bring to the process and the diffusion process, and then to the denoising process. Now, I have seen enough times diffusion process and denoise process, and you still don't know what it is. So let me explain that little thing. What you are gonna do, the diffusion process is basically giving, let me remove the annotated. There is a way of removing everything. Yeah. The diffusion process that we see is basically adding noise to the image. You know that the image, if we can see the RGB of every image, every image is, every pixel in an image for real is just a combination of 3 colors, right? So you can add noise, which is changing one of these colors randomly to each one of the photos until at the end, you just have a picture that is only noise. This is the diffusion process, which if you see the diagram that it's been on the paper of on stable diffusion. This is a diagram that it has in the paper that explains diffusion process. This is the diffusion process. Now, in all honesty, this diffusion process is just programmatically. This is not machine learning just yet, because you can do that randomly, recurrently to an image, until the end you just have a noise, an image with noise programmatically. The part that is machine learning is that the noise version, because at the end you can train the program so it will see an image with only noise and it will clean the image in just one step to know, to have a recognition of what that image was. And this is the basic of stable diffusion, and is the machine learning process, and it's doing it something because we need to encode the image in a little matrix. We are doing this whole process in something that computer science called latent space, which is inside the GPU, which is that makes that whole process could happen in just one step, not in all the steps that happen at the end of the during the diffusion process. Hope that is clear. Remember, there will be time for questions at the end of the presentation. Now, why using a stable diffusion? Why is so popular? Well, for the first one, it's free, kind of, except that you need GPU cost, that you need to take account GPU use, because you're still doing high level calculations to image. The second reason is that it's open source, and that's the bigger difference with all other models of generative AI that are there in the industry at this moment. And being open source is actually a great thing to see how many people keep contributing and finding different uses and different things to tweak the foundation model and making the process faster. And I will show those process in a minute when I show all the code to all of you. Let me stop the annotations. And the second one, it has so far is one of the processes that require low computational requirements. Low in comparison with the other ones. It's not that it's actually low. For example, I could not run the model in my computer. My computer has a very basic GPU and it was super slow. So that's the reason I'm doing this in a Google Colab that I show you in a minute, because basically Google allowed me to rent a GPU a very powerful CPU for just $9. So it's not strictly free, but it's access is one of the most accessible at the comparison of all the models that are there. With that, let me see what is next. Seem to see the notebook. Yes. So let me stop sharing this presentation and let me show again. You will receive links of all of these things that I will show you here. So don't worry too much about following the links. This is a Google Collaborate Lab. I hope that you are familiar with an Jupyter Notebook concept. But if not, Python, you need a virtual environment where you are running Python in your computer. Um, so this company, Jupyter, developed this idea of a space in the browser where you can run Python. It's very cool because allows you to run Python in a virtual environment that is could be shared in your browser. That is something that doesn't happen normally. And Google Colab, which is the platform for doing experiments on Google computers, machines, works with Jupyter notebooks to have these kind of things. And you will receive a link of this one, so don't worry too much. But basically, this is a collab. This is how it looks, and it tells you where are you connected. I'm connected to a GPU. If you can see here, I cannot move my mouse. But if you can see here, and I can make this bigger if you need it, I have 7 gigas of RAM and I have a huge disk. And that's the reason that allows me to run the model very quickly. With a Jupyter notebook, everything that is styled with an exclamation point is something is similar that you are typing to the um, terminal. So this is just installing the package that I needed. And it will tell you very quickly at what moment is already, well, I already did this, so it's only telling me that my requirement is already satisfying because I just did this before the workshop. This is real Python. Anything that it doesn't have an exclamation point in a Jupyter node is what is you're doing. But if you look in, it's still just important and using basic configuration. This accelerate process is what allowed me to write this in code, that image, and making the process faster because I'm now working in something that is in code. These are just more Python package that I needed. And here is the code for the diffusion process. And if you check, it's just a list of 10 lines of code with the process that you need to do. What do you want to do? If you check the code that if you check, I will not run this because I will run the code the whole process again, and it will trying to train the model again, and I don't want to do it that line. But basically, the thing that you are doing, the thing that you are doing is just telling that you are using diffusion, stable diffusion version 1.5, and that's it. Python does the rest for you. Because stable diffusion is open source. So this package of Python has the whole stable diffusion, and you download that whole code for free. And you have access to that foundational model. And that's the amazing thing. I cannot download this to my local machine. I need to work in this machine of Google, but still I have access to the whole model again. Uh, I don't know if it's not impressive for all of you, but for me, it's super impressive that you have access to a foundational model of generative AI, and you can actually download it and work with it for free. And that's the magic of open source. Well, it's not quite free. I pay for the GPU, but I pay only $9. Um, the the model work with two things. One, the definition of a class, and inside the class, the definition of an instance. So because for this experiment, I will do an image of myself. The class will be a photo of a woman. If you are familiar with the idea of object-oriented programmation, um, a class is the bigger classification of something that you want to work. If we will work with cats, the class will be animals. And if we will work with um, water, the class will be drinks or something like that. And because it's my photo, which I trained this model with my photo, the only thing that I need to do in the instance is give me the prompt a photo of and something unique. You need to give the model something unique that it recognizes that is you, is not part of of the big collection of data that is being trained. Um, Remember that Stable Diffusion was already trained. They already did with the Stable Diffusion, they already did um, this process, this diffusion process. This whole model is the thing that you are downloaded here. So this model is already trained with a huge amount of image of internet. And that's the reason it recognizes what is a photo of a woman. The thing that I'm training and the thing that you are fine tuning is recognizing that it recognizes a photo of me. But me is not an identifier. So my identifier is just my two initials and my last name. But you can change this to be anything that you wanted. And the other thing that you need to do is put photos of yourself. So if you see here on the folder of the identifier, check that this identifier has to be the same. I have photo of me. It works better with 7 or more, but for a space, I'm only using 6. If you see these photos, I can show you. These photos are just photos of me. I just want that the model train to recognize my face when it thinks of the photo of a woman. It works better the more photos of you give the model. So that's the reason the original meetup page says no less than 7. I will recommend work with them with 10, and then you run the model and it tells you how it recognizes your photo and how many steps took to recognize your photo, which is pretty cool. This is just the part of the program that talks directly to the GPU. CUDA is a language, a programming language to write things directly to the GPU because I want to save the content of the model into the GPU. And that is what these 4 lines of code are doing. And it saves everything as a JSON, very similar. And here is where we can test if the model is training correctly or not. You can, so the prompt is the text that you will give to the model. You can search from pretty much everything, but it has to have your identifier. And when it runs the prompt, it calls the pipe with the prompt, the number of interrupt space steps. It means how many times it will do the process of adding noise. And giving a scale is how much attention and how much attention we'll give to the prompt. So if I change the steps and put less steps and less attention to the prompt, it will be actually an image very different than me. And look how fast it is working. To see how it really is not my face there at all. But I manipulate the image. The more steps you do, the more training you put to the process, to the model, and you can put, I don't know, an 8 of being focused on the prompt, and you run the model again, and now you have different image of yourself. It's not that great, but it's super fun of doing something like that. And you can have a lot of problem finding with current prompts. I'm not a prompt expert, but there is a tool, it's called Lexica, where you can search with stable diffusion. So the thing that I do here usually is that I search for the thing that I want to imagine, and I put the prompt, I copy the prompt. So let me see how this will work. And look at that. I have a photo of me as an astronaut and high resolution. Stable Diffusion has a lot of problems with AIs and with hands. I don't know if you have seen the memes that somebody is learning to draw and I have problems with hands, and AI is learning to draw and has problem with hands. And usually how you can recognize image doing on, but as a part of the as a product, as a part of a project for trying to understand what are you doing with generative AI, generate this kind of image is very easy. And I will give you access to this link in the handout, and you just need to run these things. You don't even need to write really code anymore, which is, I think, imagine it's magnificent. And then you have this here in a Google Code Lab, which is not something that you want to use for your project, because the only thing that you can do here once the model is here is copy the image. I mean, I can copy the image and use the image if I wanted, but you cannot use this in a project. And my idea when I did this whole is how I can use this in a project. And that brings me to my next tool, which is Hugging Face. Hugging Face is basically a space for sharing models. It's the platform that people is using for sharing generative AI models. You can search for the model that you wanted. Even it's not only generative AI, there are natural language processing models and a bunch of others. But basically, it's an organization that allows you to put in just one space your model your trained model, once the model recognizes you and understand who is the image of you, you can put that here and it gives you an API, which is the thing that you want to do. So I put the whole model here. I did that. I will show you in a minute, but basically you create a couple of files of Python and now your model is here. And because it's here, it gives you um, it gives you API calls, API keys, API calls, and then you can call your model here. It gives you logs, it gives you everything that you needed, really. And also for free. This well, it's not free if you use it way too much, but the free tier allows you a bunch of free calls, so it's not that expensive. And let me show you how I did that. You can see that in my GitHub. My GitHub, you will have access to this again. But basically, you need to have these two lines. These two, one, just importing the the training model from the Google Colab, and then Google Colab, and then creating this. So install all the Python dependencies in your local key with your key for the model. You have access to this one, and you don't need to change anything of this code. You just need to change your API key when you are in Banana. Um, and that will allow you to call, if you see the documentation of Banana docs, how is to say that Banana is a great name for a platform, and they do because Banana for scale, which is an amazing thing. But if you do the documentation, it's very simple to run a project, to run a model, and even standing with Python again. I just copied this whole thing. Is the same that you see here in my code. I'm not doing anything different from Banana, and that allowed me to run my model. I can run it in my local. So now I can run it here. Not here. This one. This one is basically the same image that I saw in the Collab lab, but in version of B64. So it will be a whole string. When you convert an image to a base 64, you convert the image to a string. And that allows to browsers to recognize the image. And that's the only thing that I'm doing here. But I can do this because I'm running this literal is the same print results that you see here. And just following the instructions of that process. I'm not doing anything different, I promise. And then I can run and see the image, and now I can even write that with this little script. So if you run this little script, you can see the photo in your local, and then you can find the photo in your local. So with that, I save photo like this one. Let me show you. Another one that I create with the model, and it's saved in the local with these 4 lines of code. And again, I will give you on the handout everything that you needed. So you will have access to all of this information. And if you have some problem, you can reach out to me. And of course, um, we can do pair programming or whatever. Now, the first time that I did this project, this was only for this workshop because I was not doing a final project with this one. But the first time that I did this project, I did it for a final project kind of project. And I did a multiverse, which is something that I publish, and you can see now. So basically, it's the same idea, just that we are part of a multiverse as the Everything Everywhere All at Once movie show us. That was my inspiration. So you can ask for photos of me. You can help me to imagine all the multiverse where I will live. But it's the same idea. And because I have that banana, I could put that in a server and basically um, create an API call where I could ask for the model inputs and save that to my server. And that's the reason I can have now the web version. And you can see all of that in my, and the web version, of course, also have a server because I'm doing the code. And this server is in JavaScript, so it's not even Python anymore. But we have a banana developed SDK for connection with JavaScript. And I'm just doing the connection with the API that allowed me to bring the data. Nothing major. I'm saving this in a SQL database, and I'm saving as image base 64. So allow me to save it just as a URL. And with that, you can show them in a grid of image if you want to do this kind of project with the API. But in reality, everything starts here in this collab with the whole diffusion that you can download and work locally and fine tune. And that allowed me came to my conclusions very quickly before we jump to the questions. AI and machine learning are distinct, are not the same thing, but they are interconnected. And you cannot talk about machine learning without talking about AI, or you cannot talking about generative AI without talking about machine learning, but are not the same thing. They are just subfields and part of this huge discipline that is called AI. Stable diffusion is the foundation model of generative AI, and the cool thing about it is that it's open source and you can download the whole foundation model to fine tune it and work it as you want it. You can use the whole stable diffusion for creating image. Imagine that you don't want to create image of yourself. You want to create image, I don't know, websites, logos, ads, whatever you want it. You already have the whole stable diffusion model in your collab. The evolution of AI technologies is rapid and significant in the last 10 years of the computer science history, but we need to talk about accessibility and best practice because one is not completely accessible, even if this one is open source, but it's not completely free. I show you that I paid $9 for the GPUs. You cannot use it in a regular laptop in your house. And it has bias. I mean, if you work in Lexica, if you work in Lexica just for a woman, it's very different the image that you see if you search for a man. You see how the image are different? It's biased because it's not magic. It's just a computational matrix of vectors that were programmatically uh, developed for someone. So we need to talk about these things. And that's the reason I want to do this workshop, because I want people from all diverse backgrounds to start using these tools and raise their hands and saying, hey, this is amazing. It is super cool, but it's not free of problems. And with that, I think I could open the floor for questions.